think about this for a second. What if the future of technology, the entire transition to green energy and global strategic power rests on a material that accounts for just 0.02% of the weight of the best-selling electric vehicle in America?
It's a question that sounds like, a bit of an exaggeration.
Right.
But it's the astonishing reality we're facing, and it's really the core of what we're going to unpack in this deep dive into supply chains and industrial strategy.
Absolutely. So to make this really tangible for you, let's look at the Tesla Model Y. It's an incredible machine, weighs about 4,388 pounds, and it's built from, well over 10,000 separate components.
A huge number of parts.
A huge number. Now, if you break that down, the most functionally critical piece of the whole car is the rear drive unit. It's actually pretty light, relatively speaking, at 194 pounds.
So less than 5% of the total weight.
Less than 5%. But the real secret, the high-performance core that dictates everything from power to efficiency, is buried deep inside the motor's rotor.
And that's where you find the magnets. But we have to be clear, these are not your standard refrigerator magnets.
No, not at all.
These are highly specialized sintered magnets. Usually they're neodymium iron boron, and they're designed to generate these incredibly precise, powerful magnetic fields. That's what gives you the massive torque with minimal energy loss. These high power density magnets are completely indispensable for an efficient electric motor.
Inside those magnets, that's where you find it. The magic ingredient, rare earth elements.
Mm-hmm.
And here's the number, the one that really should make you stop and think.
Right.
A Tesla Model Y uses only 1.1 pounds of these rare earth metals.
Just one pounds.
That's the 0.02% we started with. But here's the thing. Without that single pound, that car would instantly become drastically less efficient. It would have to be heavier, far more expensive to build because you'd need bigger, bulkier alternatives. The whole design gets more complex.
So that 1.1 pounds is quite literally the linchpin of the whole technology.
It is. So, to set the stage properly, let's define what we're actually talking about. What are rare earth elements, or EEs?
Right. So REs are a group of 17 metallic elements. You'll find them near the bottom of the periodic table. It's the lanthanides, plus scandium and yttrium. And here's a common misconception. They aren't actually that rare in the Earth's crust.
Okay, that's surprising.
It is, but the name is a bit of a misnomer. The problem is they're rarely found in concentrations that are high enough to be economically mined. And more importantly, they are chemically almost identical, which makes them incredibly difficult to separate from each other. That difficulty, that's what makes them so valuable.
That separation process.
Yeah.
That's the key.
That's the whole game. And these elements, once separated, are absolutely essential for almost every piece of modern high-tech you can think of.
We're talking about the bright, vivid colors on your phone screen or your TV.
Those are phosphors, yeah.
The tiny, powerful speakers in your phone, the guidance systems in, critical military hardware, the massive offshore wind turbines that are powering our grids.
And of course, the lightweight, hyper-efficient motors in every single electric vehicle. You just can't build the modern world without them.
So, given how critical they are, what's the geographical reality? Where do we get them from?
Well, the sources we've been digging into lay out a pretty sobering fact about the current supply chain. Right now, China controls about 70% of all rare earth mining production, the actual digging it out of the ground.
70% is a huge number for any commodity.
It is, but as you said, the story doesn't end with digging dirt out of the ground. That raw ore is useless until it's processed.
Right, it needs to be refined.
It needs to be refined. The metals have to be chemically separated in this highly complex, intensely energy-intensive, and frankly, notoriously polluting process. And when you look at that side of the supply chain, the refining and processing China's control, it just skyrockets.
To what?
They control an overwhelming 92% of the global production of refined rare earth materials.
92%. Just think about that number for a second. That level of dominance in a critical strategic resource is almost unprecedented in modern history.
It really is. And that staggering figure, that defines the mission for this deep dive. Because the United States was the leading global supplier of rare earths as recently as 1991.
From the Mountain Pass mine in California, right?
Exactly. So the core question we have to answer is, how did the U.S. go from being the world leader just 3 decades ago to a situation where China now dominates the one mineral the entire modern world cannot live without? How did they establish this functional choke point on the global supply chain?
The journey there. It involves decades of really focused, meticulous strategic planning by China. But it was also paired with what you'd only describe as profound strategic negligence from the West, A lot of self-sabotage, really, often driven by short-term commercial thinking instead of long-term policy.
Okay, so let's explore the gravity of that control, because it goes way beyond just, whether a car company can be profitable. This is a matter of state power.
It is. The reliance is everywhere. As we said, it's that small quantity, the half a kilogram in a Tesla,
Yeah.
that has this massive impact. It's what allows for the miniaturization you need for modern battlefield sensors, for precision guidance systems.
It's also about energy density in battery systems, superior performance in the propulsion for, say, advanced aircraft or submarines.
The geopolitical reality here is stark. One of our sources puts it this way: China controls whether or not the world has an EV revolution.
That is a stunning statement.
It's an incredible statement about an industrial choke point. It basically implies that if Beijing decided to restrict exports, the ability of entire nations, Germany, the US, Japan, to transition their energy grids and their transportation systems could be, well, fundamentally paralyzed.
And we don't have to guess about this. We don't have to speculate about them using this leverage. We've seen them not just recognize this power, but actually start to activate it.
They fired a very clear warning shot.
A very clear one, yeah. It demonstrates exactly how they plan to use this dominance.
This brings us to a really critical piece of source material. It's China's announcement number 62 of 2025, which was published on October 9th. And this wasn't just a simple tariff or a tax. It was a much more sophisticated tightening of bureaucratic control.
So what does it actually do?
It introduces new rules that require foreign companies to get specific government approval to export products. And this is the key part. It's not just for raw rare earths, but for finished products, where REEs account for just 0.1% of the goods' total value.
0.1%. That is an incredibly low threshold.
It's tiny. And that's the whole point.
Yeah.
It's the mechanism for a massive expansion of control and intelligence gathering.
Exactly. So this isn't about controlling the raw dirt anymore. It's about controlling the entire manufacturing output that uses their refined material downstream. So if you're making, say, specialized medical equipment or high-end robotics or advanced defense components outside of China.
And less than 1/10 of its value comes from a Chinese-supplied rare earth magnet.
Beijing now claims oversight. They get a say.
So what does that 0.1% rule really mean in practice for a foreign company? I mean, it forces them into a compliance nightmare. To prove you meet that threshold, you have to share detailed proprietary supply chain information.
You're talking product specifications, component origins.
Everything. You're handing it over to Chinese regulators. This massively increases Beijing's intelligence gathering capability. It gives them, a clear window into the production secrets and the weaknesses of their global competitors.
It moves the leverage from just economics into, well, strategic industrial oversight.
And the reaction from the U.S. was immediate and very telling. It showed just how acutely this dependency is now felt. President Trump responded almost instantly, threatening to impose an additional 100% tariff on all Chinese goods.
That public tension, that trade dispute, it just illustrates that this isn't some niche mining issue anymore. This is a high-stakes geopolitical contest where control of this tiny amount of material has become a real economic weapon.
And this problem isn't going away. In fact, it's only going to intensify. The demand figures for the future really underscore why this control is so critical. Demand for rare earths is projected to surge.
From what to what?
From about 91 kilotons in 2024 to an estimated 150 kilotons by 2040.
So a 65% increase, and that's driven mostly by the global scale-up of EV production and renewable energy infrastructure.
Exactly. Which means the geopolitical leverage that China holds right now is only going to grow exponentially over the next decade and a half. The stakes just get higher every single year.
Okay, so stepping back from the immediate politics, let's get into the how. How did China achieve this? This wasn't just an accident of geology.
No, not at all. They turned dirt into global strategic leverage. It took decades of focused strategy and, as we said, a surprising amount of help from the West. And that story really begins back in the Cold War.
Right. China was operating with this profound strategic foresight. They were watching the U.S. and the Soviet Union very, very closely, and they made a foundational observation.
Which?
That rare earths were the literal backbone of America's most important industrial and military sectors. They saw how necessary these elements were in things like petroleum refining, where they're used as catalysts, in precision hardware, metallurgy, and especially in military hardware.
Things like radar and guidance systems.
Exactly. So this wasn't just about commercial planning for them. It was a matter of state security and long-term national ambition. They understood that if China was ever going to compete with the U.S. on the global stage, militarily or economically, it had to develop its own powerful, independent technological base.
And they saw these minerals as the insurance policy for that future.
It was their insurance policy. And that realization, it led to the institutional groundwork being laid very early on. In 1975, long before EVs were even a serious thought, China established a national rare earth development and application leading group.
So this was central planning in action.
Pure central planning, and it directly resulted in a meaningful long-term ramp-up of R&D funding. It spurred focused academic research into the highly complex world of extracting, refining, and applying these elements. They weren't just digging randomly, they were systematically figuring out how to dominate the underlying technology.
But here's where the story takes a turn. Here's where the U.S., as you put it, had an open hand. A moment of really profound misjudgment in the 1990s that essentially gifted away its competitive edge.
The sources are very clear on this. China specifically sent waves of scientists, engineers, and geologists to visit the U.S. Mountain Pass mine in California.
Which at the time was the global leader.
It was the global leader in rare earth extraction and processing, and the welcome these Chinese delegations received was, well, astonishingly open.
The CEO of Molycorp, the company that ran Mountain Pass, was quoted describing these visits. He said they literally toured the Chinese scientists through the entire plant.
They explained their proprietary processes for solvent extraction. They allowed them to take copious photographs.
And this is the part that's just unbelievable. They even permitted them to take rock and process samples back home to China with them.
It was, for all intents and purposes, a free, high-level industrial espionage tour authorized by American business leaders.
I have to stop there. They let them take rock samples and effectively the blueprints. In hindsight, that sounds less like negligence and more like corporate self-destruction.
It does now. But you have to understand the thinking at the time. This was the post-Cold War era, full of optimism. The prevailing belief in Washington and in corporate boardrooms was that if you welcomed Chinese researchers, if you fostered trade, you would help China on its path to liberal democracy and global integration.
A fatal miscalculation.
A fatal miscalculation. The U.S. leadership simply didn't grasp the strategic weight of the intellectual property and the process knowledge they were just handing over.
And here's a part that's easy to miss, but it changes everything. While the U.S. saw rare earths as this sort of small niche part of the mining industry, not really worth protecting or treating as strategic, the Chinese perspective was completely different.
Right. There's an anecdote from a businessman, Mitchell Presnick, who recalled meeting with a Chinese mining company back in the 90s, and he noted that even then, they knew that rare earths were more important than we seem to be acting like.
They saw the future. They saw the efficient EV motor, the wind turbine. The U.S. just saw the next defense contract.
Exactly. And what was the practical result of that knowledge transfer? China took that freely acquired technical information, those processes, and they rapidly applied it to develop the Bayan Obo site in Inner Mongolia.
Which had a superior geological resource to begin with.
A much better resource. Yeah. And that site quickly evolved to become the single most dominant rare earth mine on the planet. They essentially took our blueprints, applied them to their better dirt, and built the entire industry of the future.
So the transfer of mining and processing knowledge was damaging enough. But the next step was, well, truly catastrophic. The transfer of manufacturing know-how, the actual IP.
Because you have to remember, the most important, highest value product you get from rare earths is the magnet itself. That's the sophisticated component at the heart of the EV motor.
And in 1995, the U.S. government approved the sale of a company called Magnequench.
Magnequench. This was the rare earths and specialized magnet division of General Motors.
Of GM, an American icon, and the buyer.
A consortium of Chinese companies.
That decision, it didn't just transfer some equipment. It transferred the core capacity, decades of American innovation, the detailed technical know-how developed under one of the pillars of American industry, all of it suddenly packaged up and sold.
And Magnequench wasn't just any company. It was the world leader in producing bonded neodymium iron boron magnets. That was the critical technology for all modern miniaturized electronics and motors.
So what happened next was, sadly, completely predictable. The sources detail how the Chinese buyers immediately built equivalent state-of-the-art factories in China using that acquired knowledge.
And then, systematically, they shuttered all the U.S. production facilities.
That single transaction, irrevocably shifted the capacity, the technical knowledge, and the entire trajectory of future magnet innovation to China. It wasn't just selling a factory. It was outsourcing the foundation of the global EV revolution before it had even really begun.
It was a brilliant, long-term strategic move on China's part. They seized the critical IP they needed to move way up the value chain. They went from just digging dirt to manufacturing the most sophisticated component, the magnets that dictate performance. This laid the foundation for their total dominance.
Now, you might assume, given all that, highly calculated strategy, that China's path to dominance was perfectly smooth. That was all centrally planned from day one.
But here's the twist in the story. It wasn't.
Not at all. The journey actually involved a period of profound internal chaos.
That's right. The central government had these long-term strategic goals, but the early implementation was almost anarchic. It reflected the speed and, frankly, the ruthlessness of a rapid industrial buildup. In 1991, when China first listed rare earths as strategic and introduced these generous tax rebates to encourage domestic production,
The floodgates opened.
the floodgates opened to totally unregulated cutthroat growth.
The sources call this the era of the Chinese cowboys.
The Chinese cowboys, yeah. And it was just this crowded field of dozens of small, highly unregulated mines engaged in vicious, often illegal competition with each other. And this had an immediate global effect. It drove prices down aggressively.
Which made any domestic U.S. production, like the early attempts to revive Molycorp, completely unprofitable.
Utterly unprofitable. No Western company with its environmental regulations and labor laws could possibly compete with those subsidized, unregulated low prices.
And the environmental costs during this period were just devastating.
Horrific. Because there was no oversight, these small operations had no regard for structural stability or environmental management. The refining process is inherently messy, but without regulation, you got severe water and soil contamination. We're talking about massive scarring of the landscape, ignoring structural integrity.
And creating literal lakes of toxic tailings, this radioactive and acidic sludge that's left over from the processing.
It got so bad that the Chinese government eventually had to step in, and not just for environmental reasons, but because the chaos was undermining their control.
There's a 2012 Chinese media investigation that actually compared the internal rare earth industry to the trafficking of illegal drugs.
That's the level of illegality we're talking about, smuggling, deep corruption. It was estimated that around 30% of all production was leaving the country completely untaxed and untracked.
But the local governments were addicted to the mining revenue, right? Which made it hard for Beijing to get a handle on it.
Incredibly difficult at first. But as the strategic importance of rare earths became undeniable as the foundation of the 21st century economy, Beijing realized it had a choice to make. And it chose centralized control over local revenue.
The major pivot came around 2011.
Right. The central government ordered authorities to conduct these large-scale, unannounced audits of mines. They started seizing assets from illegal operators and literally destroying operations that didn't comply. It was a dramatic, centralized clampdown.
All aimed at eliminating the cowboys and establishing control.
And the consolidation that followed was swift and profound. Within just 4 years, post-2011, the entire rare earth sector went from dozens of these small, often illegal players to just 6 super-sized firms.
The Big Six.
The Big Six. And these were all state-backed giants.
So this consolidation offered massive strategic benefits for the state.
Huge benefits. First, it suddenly became far easier for the government to track extraction quotas, production volumes, and exports. This was incredibly effective at destroying those smuggling operations that had been siphoning off so much of the product.
But more importantly, this state-driven consolidation achieved the ultimate strategic goal. It created an effective oligopoly that could unilaterally control global prices and supply.
This wasn't just about cleaning up the environment. This was about cementing global industrial control through market manipulation.
And the numbers here, they really drive home the power of that control. We often talk about the leverage of OPEC, which controls, around 40% of global oil production?
Right, and that 40% gives them immense strategic influence.
Immense. China, on the other hand, now controls 90% of global refined rare earth production.
90%. That figure makes China's dominance unprecedented in modern strategic commodities. When it comes to rare earths, it truly is China's world. The rest of us are just navigating it.
Now, this absolute dominance, it didn't happen in a vacuum. China was very thoughtful in its strategy, but the West played a crucial and quite unintentional role in its own downfall.
Especially through policy failures that were rooted in a misunderstanding of long-term economic strategy.
We've already covered the knowledge transfer. the scientists visiting Mountain Pass, the sale of MagnaQuench. But the final and maybe the most devastating blow to Western capacity was an international legal action taken by the West itself.
It was a moment where winning the legal battle meant losing the strategic war.
So to set the context here,
Yeah.
around 2005, China started tightening its exports of rare earths. They were limiting quotas. Predictably, this drove global prices sky high.
But that price increase actually created a crucial window of opportunity for the U.S.
How so?
Well, Molycorp, the company that used to run Mountain Pass, saw that these high prices, some elements were hitting $50 per kilogram, made it financially sensible to revive the mine, to reintroduce domestic production and even domestically manufactured magnets back into the U.S. supply chain.
So the high prices were the only thing that made operating in the highly regulated U.S. environment profitable?
Exactly. But instead of allowing that market mechanism to rebuild domestic capacity to create a local failsafe, the U.S. and its allies took aim at China's export limits.
In 2012, the Obama administration, along with the EU and Japan, sued China at the World Trade Organization, the WTO.
The core accusation was that China was using export quotas to unfairly restrict global supplies and drive up prices, which, violated trade agreements.
And the WTO ruled in their favor. The ruling came down in 2014. It concluded that China's export quotas were indeed unfair protectionism.
So China said, fine, we'll comply, and they officially abandoned the quotas.
And what happened next is a textbook example of a Pyrrhic victory, a victory that cost you more than losing would have.
The legal win immediately triggered the industrial collapse of the West's rare earth industry. Supply, which had been constrained by those quotas, flooded the global market.
And prices absolutely collapsed. That element Molycorp needed to sell for $50 a kilogram suddenly plummeted to below $10.
And Molycorp, unable to compete with this new flood of cheap, subsidized Chinese supply and lacking the deep state subsidies of the Chinese Big Six, went bankrupt in 2015.
So the net result of the U.S. winning the WTO lawsuit was the utter destruction of its only domestic production capacity. It left America with 0 functioning rare earth mines and cemented China's chokehold.
Now, just think about the strategic blindness involved there. The U.S. was fully aware of the strategic importance of these materials. A 2010 Government Accountability Office, the GAO report, explicitly warned Congress about potential supply disruptions for defense.
Yet the policy response was focused entirely on forcing China to sell its product cheaply, not on protecting or subsidizing a local failsafe like Mountain Pass.
They completely failed to realize that the only real protection against a supply shock is having your own domestic capacity, insulated from those external market forces.
And the strategic blind spot was even bigger than that when you compare what the U.S. was focused on versus what China was focused on.
While the U.S. was obsessed with access to rare earths for defense applications in that lawsuit, China had already identified a much broader goal: achieving industrial dominance in the future green economy.
What this really means is that China had listed new energy vehicles, EVs, as one of its top 16 priority technologies for national development as early as 2006. They were playing a much longer game.
A much longer game. They saw EVs not just as a commercial product, but as a path to global industrial leadership. And they backed this vision up with colossal central funding and industrial policy.
In 2008, they launched the 863 Program EV Initiative, pouring hundreds of millions into battery R&D and hybrid prototypes.
Then, in 2009, they launched the aggressive 10 cities, 1,000 vehicles pilot program, which subsidized entire fleets of electric buses and taxis in major cities across the country.
And China understood that rare earths were the linchpin for all of this. They enabled the efficient motors, the lighter weight necessary for global EV dominance.
Yeah.
They openly talked about this connection between resource control and EV leadership.
Meanwhile, the U.S. lawsuit, fixated almost solely on maintaining access for defense supply chains, didn't even contemplate the need for rare earths as the foundation of the coming EV revolution. The focus was entirely on defense, completely missing the industrial future.
It's an oversight of profound, lasting consequence. While the U.S. was trying to force China to adhere to present-day trade rules for the existing market, China was executing one of the greatest industrial strategy comebacks in memory by targeting and securing the foundation of the global market of 2040.
And that brings us to the final and perhaps the most difficult barrier for the West in trying to catch up:
The sheer environmental and cost difficulty of processing these elements, this is the reason China holds that 92% share of the refinement market.
Right. Refining is the crucial bottleneck. It's what defines the strategic landscape. It is intensely energy intensive. It requires the repeated use of strong acids, sulfuric, hydrochloric, in a process called solvent extraction. It's essentially a giant, continuous chemical separation puzzle.
And it produces huge amounts of toxic tailings, waste products.
Vast amounts. And they're often laced with heavy metals and critically low-level radioactive isotopes like thorium and uranium, which are frequently co-located in the same ore bodies as rare earths.
So this is why that 92% refinement share is so hard for the West to replicate. It's not just about cheap labor in China.
Not at all. What makes a U.S. operation unprofitable is the regulatory environment needed to protect public health. The sources note that repeated radioactive wastewater leaks, a common byproduct of processing and tightening EPA regulations, made it economically impossible to operate profitably in the U.S. without massive state subsidies and environmental indemnification.
China, on the other hand, well, they accepted those environmental costs during that chaotic early phase we discussed. They basically externalized the cost to their own land and their own population.
And they maintain a no-nonsense energy policy. They use whatever energy sources are available, primarily coal, regardless of emissions. That drastically lowers the operational energy cost compared to a Western company that's bound by climate goals or has to use expensive low-emission energy sources.
We are seeing some attempts by the West to hedge against this control, though. Projections suggest that by 2040, China's refinement dominance might drop slightly.
Maybe to around 78%, yeah. With Malaysia potentially accounting for 12% of refinement, largely due to Australian investment, Malaysia is often held up as the West's key strategic alternative.
But we need to look closer at that alternative because it's deceptively weak, isn't it?
It's very weak.
Oh.
Because the refined material from Malaysia, even though it's processed outside of China, will likely still need to be sent through China to be made into those finished, high-performance magnets that everyone actually needs.
Because China still holds the know-how, the IP.
They hold the specialized manufacturing know-how, the massive industrial scale, and the intellectual property for magnet manufacturing that they got from the Magnequench acquisition decades ago.
Yeah.
So the strategic bottleneck just shifts from raw refinement to specialized component manufacturing. You're still dependent.
There is some technological hope on the horizon, though. The West is exploring new techniques like ionic clay leaching and solvent recycling, especially for urban mining from e-waste.
Right, trying to find cleaner, more efficient ways to get these materials that bypass traditional mining.
But the economic barrier is immense.
It is. Current estimates show these alternative Western technologies, while cleaner, are somewhere between 2 to 4 times more expensive than the established, highly scaled Chinese processing methods. And frankly, China is also investing heavily in these next-gen technologies.
So there's no guarantee the West will even have a technological advantage.
Not at all. Because they have the scale and the talent pool, they're maintaining a lead in developing future solutions, too.
So the final assessment from the sources is pretty clear. China is just way ahead of the West.
Way ahead. And unless there is a coordinated, massive, government-backed action by Western nations, and that means heavy subsidies, protection from environmental liability, and explicit industrial policy aimed at building an entire end-to-end supply chain.
From the mine all the way to the finished magnet.
Exactly. Unless that happens, this dominance will continue to provide China with unmatched negotiating leverage over the future of global industry.
It's important for you to remember that the true value of these rare earth minerals, it isn't in their commodity price per pound. It's in what they enable.
They are the invisible, non-negotiable foundation of the entire 21st century economy. The technology that powers EVs, robotics, AI infrastructure, and advanced defense systems. And when one country holds the key to that foundation, every other geopolitical discussion, from climate policy to military capability, is framed by that singular, stark reality.
It's just fascinating to see how quiet, patient, long-term industrial policy backed by state funding and opportunistic knowledge acquisition can achieve what military conquest or even direct confrontation sometimes cannot. It's a conquest achieved through industrial process.
And if we connect this to the bigger picture, what does it fundamentally mean when one country, through a mixture of its own strategy and external negligence, can decide the pace and direction of your entire industrial future? The sources offered a really profound, reflective thought on this.
What was that?
The master does not seek to conquer, yet all are conquered. The lesson here for you is that true strategic power can be achieved not through obvious force, but through patient, relentless control of the foundational materials and the manufacturing know-how of the modern age.
It leaves us with a thought then. What other critical, seemingly insignificant materials are we currently neglecting that could define the next decade of global power?